Hello, everyone. Welcome back to the Riot Science Club. For those who are here for the first time, Riots is a seminar series that promotes a reproducible, interpretable, open, and transparent science. We have multiple centers all over the place running seminars, but all of them are shared on our YouTube channel. So if you want to keep up with what we're doing, please do follow us on Twitter and on YouTube. Just for a bit of housekeeping before we start with today's seminar, it's the usual format. We'll have the speakers speak for roughly 40 to 45 minutes, and we're going to have a bit of time for questions at the end. You can ask any questions throughout the talk as you wish, pop them in the Q&A box, and if you see any questions that you would like us to focus on, please make sure to upvote them so that we can make sure to answer those first. So today we have two speakers. So we have Professor Dustin Scheinost and Matt Rosenblatt. So Dustin is an assistant professor in the Department of Radiology and Biomedical Imaging at Yale School of Medicine. His research interests include functional connectivity, predictive modeling, software development, and fetal-infant fMRI. And in addition, Dustin is a founding member of the Fetal-Infant and Toddler Neuroimaging Group. Matt is currently a biomedical engineering graduate student into Multimodal Imaging, Neuroinformatics, and Data Science Lab at Yale University. And his main research focus is evaluating and improving the trustworthiness of machine learning for neuroimaging. And Dustin and Matt are going to be giving this talk together. They're going to be sort of alternating. My understanding is Dustin is going to go first. So I'm just going to let you take the scene, Dustin. Thank you.
Thanks. Yeah, thanks for the introduction. Thanks for having us. So to just start real quick, I just want to give a small background on how we got into this topic. It's kind of different for us. Obviously, based on those intros, we generally do neuroimaging, functional connectivity work. So how did we get into self-citation research? Well, so it kind of started almost a little bit by luck. We were basically, it's just kind of going through some standard reviewing papers. I noticed a few at one point, just a lot of self-citations in a couple of papers. I ended up making a comment on that, and I just basically got into not back and forth, but a good discussion with the editor about both when and how to bring those up, but then also what that meant. From that, then I started to look at my own self-citation rate, just to kind of gauge of what actually I was doing. And then from that, it spawned off this kind of interesting topic of looking beyond and trying to automate some of these things and look at some broad trends of these. So with that, Matt, go take us away down this journey.
Sorry, can you hear me now? I was having trouble unmuting.
Yeah.
All right, great. Thank you so much. Yeah, so thanks, Dustin, and thanks, Alexandra and Olivia, for this opportunity. Today, we'll be talking about trends in self-citation rates in neuroscience literature. So as a brief overview, first, we'll talk about the motivation for studying self-citation, then some information about baseline self-citation rates, and then we'll look at trends in self-citation rates over time, by seniority, by country, by gender, and by subtopic. And then finally, Dustin will present our Python tool, as well as some information on his own self-citation rates. So first, why do citations and self-citations matter? As many of us know, citations can kind of be seen as a currency in academia, and previous works have shown that citation practices in neuroscience are biased by gender and also by race. If we look at this figure from the Dworkin paper, we can see that papers that have men as first authors and men as last authors are cited much more than expected, whereas papers that have women as first authors and women as last authors are cited much less than expected. And this is obviously bad and unfair, especially when citations play such a crucial role in hiring and grants and many more things. Now, self-citation practices, or how much you cite yourselves, are also biased by gender. That was shown in a broad analysis of many fields by King, as well as an analysis in neuroscience by Dworkin. And self-citations are particularly important because each self-citation not only gives you one extra citation, but it also increases the visibility of your paper and increases citations from others by approximately 3 after 5 years. So to study self-citations, we downloaded data via Scopus and the Bibliometrics Python API. Our dataset included 63 journals representing the highest impact factor journals in neurology, neuroscience, and psychiatry. Our data spanned from 2000 to 2020 and included 157,000 articles and over 8 million total citations. Now, before we get into the analysis and results, I do want to define self-citation here. So there's typically 2 possible definitions. The first is self-citation on the author level. This is the proportion of an author's total citations received from self-citations. For example, if I had 5,000 citations, but 500 of those came from self-citations, then my author level self-citation rate would be 10%. Now, the second definition is at the article level. So for a single article, this is the proportion of cited papers on which the citing author is also an author. And we think that this article level better reflects intention because it's how much you choose to cite yourself in any given paper. And it's also more actionable at the time of manuscript submission because you can actually look at the level of a single article and adjust self-citations as needed. Because of these reasons, we're going to be using the article level self-citation definition throughout this presentation. And just to solidify this a little bit more, let's consider a hypothetical example of a paper by authors A, B, and C with 100 references. So if author A is an author on 5 of these references, then we're defining the first author self-citation rate as 5%. If the last author, author C, is on 10 of these references, then we're defining the last author self-citation rate as 10%. And finally, if at least one of A, B, or C is an author on 18 of these references, we would define the any author self-citation rate as 18%. And throughout the rest of this presentation, we're going to be using these definitions of first, last, and any author self-citation rates. And one last thing before we get into the results, we did want to verify that our Python code gave self-citation rates that are similar to what we obtained by manually calculating self-citation rates. So for about 900 articles from a subset of psychiatry journals, we went through and manually calculated self-citation rates. In general, we found really strong agreement between the manual and automatic scoring. Here on the x-axis is the manual scores, and on the y-axis is the scores obtained via our Python code. All right, so the first thing we wanted to do is just look at self-citation rates in the recent years, which we define as the last 5 years of our data set from 2016 to 2020. And we think this is pretty useful just to establish baseline self-citation rates in the field. And then if you want to calculate your own self-citation rate, you can compare this to the baseline. So if we look at the overall self-citation rates across all these 63 journals, we found it's about 4.5% for first authors, 8% for last authors, and 14% for any authors. And these numbers in parentheses represent bootstrapped confidence intervals of this mean value. So we ran a lot of permutation tests, and first we compared first authors and last authors. We found that last authors cite themselves significantly more than first authors, and this is not surprising because generally last authors are more senior and have more papers to self-cite. And we also ran several comparisons between the fields. So you might have noticed that in the neuroscience field, the self-citation rates seem lower compared to neurology and psychiatry. So we did run those tests to compare first, last, and any author self-citation rates in neuroscience to both neurology and psychiatry. And after multiple comparisons corrections, we still found significant differences in all cases. Then we compared first author self-citation rates in psychiatry and neurology and found that the self-citation rate in psychiatry was significantly higher in neurology for first authors. However, for last authors and any authors, the self-citation rate in psychiatry was significantly lower compared to neurology. One important caveat here, we are reporting the mean values of self-citation in various fields. However, there is very much a large interpaper variability. So here on the x-axis, we have self-citation rate, and on our y-axis, we have just the density histogram. So the green is first authors, the purple is last authors, and the orange is any authors. You can see first authors cite themselves less than last authors, which is less than any authors. However, there are quite a few papers out in these tails, meaning that there is a lot of variability between articles in self-citation rate. So the next thing we decided to look at is the trends over time in self-citation rate. Here on our x-axis, we have the year from 2000 to 2020. And on our y-axis, we have the self-citation rate. And we looked at this for first authors, last authors, and any authors. Just by looking at this, you could see any author self-citation rate might be slightly increasing. Last author self-citation rate looks pretty constant, and first author self-citation rate seems to be decreasing. So in numbers, we see that first author self-citation rate is decreasing by about 1% per decade. Last author self-citation rate is not significantly changing. And any author self-citation rate is increasing by about 0.5% per decade. So the increase in any author self-citation rate is not necessarily surprising because in general, today compared to 20 years ago, more people are included on author lists, which would make sense that any author self-citation rate would naturally increase. However, the potentially concerning thing to monitor is that first author self-citation rate is decreasing while last author self-citation rate is constant. Here you can see these are almost equal, whereas in 2020 there's a much wider gap. And since first authors are generally more junior, last authors are generally more senior, we just want to monitor this and make sure that trends in self-citation rate are not differentially benefiting more senior authors. So we also looked at the temporal trends in neurology, neuroscience, and psychiatry. So here we have year on the x-axis and self-citation rate on the y-axis. And we can see that any author self-citation rate is increasing by about 1.8% per decade, which is more compared to the general neuroscience literature. Last author self-citation rate is slightly increasing, and first author self-citation rate is decreasing. Now, interestingly, in neuroscience, first, last, and any author self-citation rates are all decreasing. However, it's important to look at these actual numbers. Any author self-citation rate is decreasing by about 0.7% per decade. Last author is decreasing by about 0.8%. And first author is decreasing by about 1.4% per decade. So even though these are all decreasing, you can still see that first and last authors were closer in self-citation rate in 2000 than they are in 2020. Next, we looked at the same trends for psychiatry and saw increases in any author self-citation rate, slight increases in last author self-citation rate, and decreases in first author self-citation rate. When we look at all these together, we can see that neurology and psychiatry, the plots look pretty similar. However, neuroscience, as I mentioned, does look different. But the really important thing to note is that this gap between first authors and last authors in 2000 compared to 2020 is widening, and that is across neurology, neuroscience, and psychiatry. In psychiatry, first author self-citation rate is even a little higher in 2000. As I mentioned before, this is potentially concerning because junior authors seem to be citing themselves less over time, and that can make it more difficult on the job market and to establish a reputation. So a natural follow-up to looking at self-citation rates over time is to look at self-citation rates by seniority. And we are using academic age as a proxy for seniority, and this is essentially just the number of years between someone's first publication and the current paper. So if we were analyzing a paper published in 2020, and this author's first paper was from 1990, then their academic age would be 30 years. Now, in this plot here, we have academic age on the x-axis and a self-citation rate on the y-axis. We're plotting this for first authors in green and last authors in purple. The confidence intervals obtained via bootstrap resampling are shown here. And in general, as academic age increases, self-citation rate also increases. This is not at all surprising because if you have more papers, you should be able to cite yourself more often. However, if we let's look at first authors at 10 years, self-citation rate is about 5%, whereas at 30 years is over 10%. And this is potentially concerning because at 10 years of academic publishing experience or at 30 years of academic publishing experience, you definitely have enough previous works that you can cite what is relevant for your current work. However, we do question whether someone with 30 years of experience should cite themselves over twice as much as someone with 10 years of experience. Ideally, we think that these trends would kind of level off a little more as compared to just gradually increasing. And next, we looked at the interaction of seniority and authorship position. So on X, we have the first author self-citation rate, and on Y, the last author self-citation rate. And each point represents, for a given academic age, the average last versus average first author self-citation rate. And this dashed line here is the Y equals X line. Somewhat follows this line, so we can conclude that self-citation rates are similar for first and last authors for a given academic age. And this would also suggest that seniority appears to be a stronger indicator than authorship position of self-citation rates. And this generally makes sense because the more senior you are, the more citations you will generally have because you'll have more papers. So in our next set of analyses, we looked at self-citation rates by country. So first, for first authors, we found the affiliated institution of this author, and then we found what country that institution was in. And for our analysis, we're only going to include countries that had at least 50 papers in our data set. Finally, we use this wonderful Python package, GeoPandas, for plotting. So here are some of the results for first authors. We can see self-citation rate ranges from about 2% to 5%. And I'll just pull out some examples here. So China and India, self-citation rates are very close to 2%. The US, UK, Italy, self-citation rates are around 4.5% to 5%. And this is a pretty big difference in self-citation rate by country, especially when you consider that citations are often seen as a metric of success. We definitely would not want those to differ too much in self-citation by country. And we did the same analyses for last authors. And once again, we only included countries with at least 50 papers. And we found self-citation rates ranging from around 5 to 8% by country. And once again, we noticed a very similar trend. Countries will use the same examples. China and India cited at about 5%, whereas the US and UK cited at about 8%. And It remains to be seen exactly why we are seeing these disparities in self-citation rates, but one possibility is just how much hiring committees and other jobs value citations compared to other metrics by country. Because obviously, if your country really emphasizes citations to get a job, then you're more likely to self-cite. So for our next set of analyses, we looked at self-citation rates by gender. And we assigned probability to each author name belonging to a woman or a man using this package called genderize.io. And then we retained all names with greater than 80% probability. And I do want to note some important limitations that these types of packages do not account for authors who identify as non-binary, transgender, or intersex. However, we do still think that this method is useful to uncover broader gender disparities in self-citation rates. And from here on, gender does not say anything about an individual author, but rather just referring to the probability of a name belonging to a woman or a man. So this first analysis is actually not self-citation rates, but we're looking at authorship by gender. So here on our x-axis, we have the year. Here on our y-axis, we have the authorship proportion. Dashed lines are for men, solid lines are for women, and green is for last authors. Green is for first authors, purple is for last authors. So we can generally see men have a higher authorship proportion, meaning the proportion of papers authored by a man, than women. And for first authors, this difference was very large in 2000 and is pretty close to converging in 2020. However, for last authors, this difference was once again very large in 2000, and it's still very large in 2020. And we just use linear fits, extend these lines to estimate when there will be equal representation of women and men as first and last authors. For first authors, these lines would intersect in about 2025. But for last authors, these lines would not intersect until the year 2052. So obviously this is not self-citations, but it's still an important thing to consider. However, now we're going to switch gears back a little to self-citations. So here on our x-axis, we have the year, and on y now we have self-citation rate. Once again, dashed lines are men, solid lines are women, purple is for last authors, green is for first authors. So if we just look at the year 2020 first, we can see first authors have self-citation rates of around 5.1% for men and 3.3% for women. Last authors have self-citation rates of around 8.2% for men and 6.8% for women. So these are some pretty substantial differences. It may not seem like much, but if you have a paper with 100 references and the difference is 1 to 2%, that's an extra 1 to 2 self-citations per paper, which then also translates into 3 additional self-citations from others. So there's a bit of a snowball effect here. And once again, we use linear fits to estimate when there will be equal self-citation rates. You can see for first authors, self-citation rates for men and women are kind of decreasing almost exactly at the same slope. So these lines would not intersect until the year 2105. Whereas for last authors, there definitely is an improvement in the gender disparity in self-citation rates. So these lines would intersect in about 2053. So even if authorship is improving much more quickly, where first authors will be approximately equally represented by gender in potentially just a few years, self-citation rates are not really improving at all. Now, this is essentially the same analysis as last slide. We have the year, except on our y-axis, just to make it easier to see, we're plotting the ratio of average self-citation rate of men to women for a given year. And for first authors, we can see generally this hovers around 50%, meaning men are setting themselves about 50% more than women, and that's not really changing. For last authors, this hovers around 20 to 25%. These 2 years, we're not quite sure what happened, but for the rest of the time, around 20 to 25%. And once again, these ratios are relatively steady over time and not really improving, which is potentially concerning. And a natural follow-up question would be to look at gender self-citation rates by seniority. So we mentioned before that seniority has a strong relationship with self-citation rate. And in general, we know that there are gender disparities in terms of hiring, especially in senior faculty positions. There's a lot more men right now. So we wanted to see if this could account for it. So we plot academic age on the x-axis. As a reminder, this is increasing in seniority to the right, and self-citation rate on the y-axis. The dashed line is for men, and the solid line is for women. And you can see pretty early on, there emerges a difference in self-citation rate. However, when we get to 40 or 50 years of academic experience, it's very noisy and you can't tell much of a difference. So we define this early career range as less than or equal to 10 academic years. And in this range, men cite themselves at 3.2% and women at 2.3%. That equates to a 41% higher self-citation rate for men during the first 10 years of their careers than women. And the difference between 3.2 and 2.3 may not seem like a ton, but once again, if you have 100 references in a paper, that's an extra 1 self-citation, which could translate into 3 self-citations from others after just 5 years. So this is the exact same set of analysis, except on our y-axis now we are plotting the ratio of average self-citation rate of men to women at each academic age. We do find very similar trends. You can see early in the career stage, it's around 40% higher in self-citation rates in men compared to women, and then late in the career stage, this drops to be approximately equal. So once again, this is potentially very concerning, especially early in the career, where citations are so important and may impact hiring decisions. There's kind of 2 possible explanations we thought of for why there may be such a citation discrepancy between men and women. The first one is the number of papers they're on. So essentially, the thought is that if you have more papers, then you have more papers you can cite and your self-citation rate would be higher. So on our x-axis here, we plotted the academic age, and on our y-axis, the number of papers. Dashed line are men, and the solid line are women. So we found in general that men are included on more papers compared to women. It's a little hard to see early in the career here, but if we look at a ratio, you can see that even early in the career, men are included on more papers than women. And this is obviously very problematic. So if we look at 10 years, for example, the average number of papers authored by men was 44. However, the average number of papers authored by women was only 30. That is a really big difference, and it could definitely be accounting for a lot of the difference in self-citation rate. And it does warrant future investigation as to why this is actually happening. One possibility is just lack of inclusivity. Another possibility is just less inclusive co-authorship networks, but this is definitely an important thing to look at in the future. So the other possible explanation for gender disparities in self-citation would be how much do men and women cite themselves for a given number of papers. So we looked at, we grouped these authors by the number of previous papers they had into 0 to 9, 10 to 19, 20 to 29, etc. And then for each of these, we calculated the self-citation rate for both men and women. The asterisks denote significant differences after multiple comparisons correction. So we can see pretty much that all these significant differences come early in the career. So what this means is that early career men cited themselves significantly more than women for a given number of papers. And it may not seem like huge differences between the bars, but for example, for 40 to 49 papers, self-citation rate for men is around 6%, for women is around 5%. So if each of your 40 papers had 100 references, an extra 1% in self-citation rate would mean 40 extra citations for you. If each of those translated to an average of 3 extra citations for others, that would be an additional 120 extra citations from others. I mentioned before, our corrected P's are significant for 0 to 9, 10 to 19, 20 to 29, and 40 to 49 number of previous papers. So this is especially important because at this early career stage where you're trying to establish yourself and accumulate more citations, this could really negatively impact some hiring decisions for women. So just as a quick recap, we found that self-citation rates for men are generally higher than women because men are included on more papers compared to women, and also that for a given number of previous papers, men self-cite more than women. So our next set of analyses are looking at different subtopics in neuroscience literature. So we took the abstract data from like the text of the abstract from our data set and then ran a latent Dirichlet allocation, which is this unsupervised topic modeling method to identify 13 topics in this case. Each of those topics is just a distribution of words. So we looked at word clouds of the most common words and then manually labeled the topic names based on those frequently occurring words. Here is a set of examples. I will point you towards this word cloud, which has functional, connectivity, control, and we assign this label of functional imaging. And we did the same for all of these 13 topics. So here we have our 13 topics: aging and development, animal models, cellular research, clinical trials, dementia, depression and anxiety, functional imaging, mechanistic research, pain, schizophrenia, social neuroscience, and stroke. And for each of these, we calculated the average self-citation rate, as well as bootstrap confidence intervals represented by these error bars of the average self-citation rate. We did this for first authors, last authors, and any authors. In general, you can see there are some substantial differences by subfield. For example, clinical trials and dementia research both show higher self-citation rates than other fields. Social neuroscience, for example, shows low self-citation rates compared to the other fields. And this is just important to understand because if you want to look at your own self-citation rate, this means that you should probably compare it within your subfield, not necessarily within the broader field of neuroscience. And one possible explanation we thought of for these varying self-citation rates is just the number of authors per paper in a given field. So if there's more authors per paper, you would expect higher self-citation rates. So we took the rank correlation between the average number of authors per paper and each of these average self-citation rates. We found it was pretty low for first authors, but moderate to high for last and any author self-citation rates. This means that at least for last and any author self-citation, that the number of authors per paper could be explaining a good percentage of that variance. The next thing we decided to look at was self-citation rates by topic and gender. So first, we did this for first authors. You can see here, this is the authorship proportion. As a reminder, that is the percentage of papers authored by men in the unpatterned bars or women in the pattern bars. And down here, we have self-citation rate. In general, consistent with our previous results, we found that 10 of our 13 topics had a higher proportion of men than women as first author. However, when we look at self-citation rate, we found that every single topic had higher self-citation rates for men than women. And this even included the topics where there were more women authors than men. We ran the same set of analyses for last authors and found that the proportion of last authors were more men than women for every single subfield. And similarly for self-citation rate, we found that men self-cited more than women across all subfields. And these results are important to consider because it shows that the difference between men and women in self-citation rate is not being driven by any particular fields, but rather it's pretty widespread across all subfields. And we do want to address several limitations of this work. So first, as we mentioned, gender assignment is limited because it's binary, and that obviously does not account for everyone. Also, we restricted this analysis to 63 journals. And this remains to be seen how this generalizes to a broader range of journals of varying impact factors. Finally, as I mentioned at the start, we're reporting mean values here, but there's obviously a lot of variability between articles. And despite these limitations, we did see several significant trends and group differences. And just to summarize these results before I pass it back to Dustin, so we saw that last author self-citation rates are relatively steady over time, while first author self-citation rates are decreasing. We also saw that academic age has a very strong relationship with self-citation rate. Self-citation rates also differed by country, and we found that they also differed by gender. For example, early career men cited themselves 41% more than early career women. And finally, we found across all topics that men cited themselves more than women. So now I'm going to pass it on to Dustin, who will talk about how to evaluate your own self-citation rate, and will also share some results evaluating his self-citation rates.
Oh, hey, awesome. Thanks, Matt. So I guess so as Matt said, we have this tool. You can, hopefully it's relatively easy to run if you ever wanted to check what your self-citation rate is. And as an example, this is what it looks like for me. As I mentioned before, some of this work kind of started just as a quick kind of discussion between an editor and myself, and just kind of got me to ask kind of what does my self-citation rate look like if I'm noticing this in others people's work. Am I you want to know what your becomes very curious what you're doing. So I just kind of want to walk through some of these, point out where maybe a few things I don't like about my own self-citation practice, and just maybe throw out a few bigger picture type questions that you might ask. So first, this is the self-citation rate.
Sorry to interrupt you. Do you mind sharing your slides, because we can't see them? I'm not sure if you're intending to share them yet.
Gotcha. Yes, I can. Thought that did it. Okay.
Perfect. We can see them now.
Okay, perfect. And let me just go back real quick. So here's the Python code itself. If you want to download it on the preprint, there's also a link to the GitHub where you can access it. So these are some of the metrics, some of my own self-citation rate. You can see it there in the histogram, and these are papers for me citing myself for any positions as an author. So you can see in general, probably the mean somewhere around, 0.1, maybe a little higher than that. But again, there's a large amount of variability in that. There are a few papers that are quite high. What is quite high is probably a personal opinion, Certainly, I'm starting to think anything with a self-citation percentage of 0.2 or, is probably too high. But those are all kind of your own personal opinions, right? How much is too high? You can see this trend as I've gotten, let's say, older in my academic age. I'm also showing that trend of increasing self-citations over time. So you can see that nice linear trend there. It'll be interesting to see what this looks like as I keep getting older in my academic age. Hopefully, I would like this to level out just from my own point of view. I don't want this to go much higher than this. I kind of agree with some of the things Matt was saying, where I think there's probably a good, we could all probably limit our own self-citations over time, or our own self-citation rate. And then finally, this is me for any author self-citation. So this is if I'm an author on a paper, whether any author is also an author on one of the cited papers, right? And you can see that does increase quite a bit from versus if I'm just citing, a paper that I'm an author on. It does increase the rates a little bit. And you can see there's probably two down there that really stand out. So one right around that 0.8 and one a little over 0.6. And one of the reasons I think those might be a little high is often we come up with new ways of analyzing data, and then collaborators would like to use those methods, and then they kind of cite all the papers describing the methods and then some of their own work in there. And actually the one at that 0.8, I will say, is in a kind of very specialized field where we had a couple of senior authors on that paper too, who did a lot of the fundamental work in the field, and it's kind of hard to almost not cite them in some ways. But I will admit, I don't like seeing those rates be that high. So I think this was, at least from my point of view, looking at these rates and kind of taking a step back on where you want to be in your own self-citation. Like I said, I don't like seeing those numbers that are that high. It's something I'm much more, after doing this project, something I'm much more self-aware of. When we're citing, are there other references that would be more applicable, better, or just even to increase diversity? I think some of the things that we certainly run into as just a general trend is sometimes we go for the easy citations, right? If we're discussing a topic that we're experts on, we probably have a review on it, or a review from the lab, or maybe even just our favorite review, and we kind of keep citing those papers. Certainly, I noticed there's a few papers that are great papers that we like to cite, but they're starting to maybe get a little long in the tooth. Maybe there's more recent reviews we can cite. Maybe there's more recent papers from other groups that bring up similar points, or maybe even bring up those points better. So, like I said, these are just my opinions on what I think I would like them to, what my rates to look like and my citation habits to look like. I think there's a lot of reasons and times when you probably, a self-citation is the best citation at hand, but I think it's also good just to kind of step back and look at your own practices. Because like I said, I really don't like seeing some of those high ones there. And with that, I can just take, I can wrap up the acknowledgements for everyone. This was a ton of work. Matt obviously led all of it and did an amazing job, but we had several co-authors who helped with the, conceptualizing some of the results, or interpreting the results, conceptualizing some of the experiments, and doing some of the manual checking of the data, the manual scoring of various journals for self-citation, so we could benchmark across that. And I would also like to thank all of you for listening to us and inviting us to give this talk.
All right, thank you both of you. That was genuinely such an interesting talk, and it's really prompted me to think about my own self-citation behavior, and I'm sure that's probably the case for a lot of our listeners, those who are here today, but also those who are going to be, listening later on YouTube. And I know as soon as this talk is over, I'm going to go and use the Python tool to check my own rates. So thank you for that. We have quite a few questions, so I'm gonna go through them in the order that they were sort of upvoted in, and you can feel free to decide between the two of you who wants to go ahead and answer it, whatever you both think is best. So the first question from Anonymous is, when you categorize the disciplines into neurology, neuroscience, psychiatry, how do you deal with citations for interdisciplinary studies that sit at the intersection between these fields?
I guess I could take that one. We just did it by, what was it, Web of Science breakdown, where they categorized the journals. So the psychiatry journals were just categorized as psychiatry journals. So certainly there's probably some, well, there's overlap. Journals can be in multiple of these categories. So there is some overlap there, which is why we did look at some of the topic modeling and, acknowledging that there's neuroscience is a big field. But yeah, sometimes it can be tricky exactly which category they're in.
All right, brilliant, thank you. The next question is from Claire. It's a bit long, so if you find yourself lost while I'm reading it, you can have a look at it in the Q&A box. So I'm just gonna start reading it now. So Claire says, sorry for the long question. Do you think self-citation rate increasing with seniority may be partly driven by an increase in specialization? So i.e., while as an ECR, you may be researching different topics for your MSc, PhD, postdoc, as you advance in your career, your papers will follow on from each other and tell a story more so than they did earlier on.
Yeah, I'm happy to, unless Dustin, do you want to take that one?
Go for it, Matt.
Yeah, so that's a great point, and I don't think it's one we had considered, so thank you very much for bringing that up, Claire. But yeah, that is a really great point, especially if you look at 10 years compared to 30 years, I would definitely agree that is the case. However, we saw that trend is kind of increasing linearly, so I think that as you get into more of the 20, 30, 40-year range, maybe that would less so be the case, but yeah, compared to 10 years, maybe that's a postdoc to 30. That's a great point.
Yeah, and I can just jump in with some anecdotal evidence with that one paper I pointed out with that really high any author self-citation rate of mine. One of the reasons for that, I think, is that mechanism, right? We had a couple of really key people in not a super specialized field, but a much more specialized field, who did lay a lot of the foundation and the groundwork that led us to the study. And so in points it kind of was hard not to cite those papers. So that could be, I do think that certainly is a factor, and that's a great point.
Thank you both. Okay, so the next question is from Anonymous. Thank you for a brilliant talk. What can ECRs do to fight excessive self-citation without putting themselves at a disadvantage?
Yeah, I can take a stab at that. That is certainly a hard thing, right? So one thing, when we posted this on Twitter and the preprint, a lot of people, noted the gender differences between men and women in self-citation practices, and some of them were saying, women should cite themselves more to equal the gap. And I agree, we should try to equal that gap, but I would almost take the other approach of trying to reduce your own self-citations, right? That's kind of my take. Obviously, you can have different opinions on that. That's just my opinion. Yeah, but how to do it in a way that is, if you're an early career researcher and you take a principled stand and you want to, let's say your opinion is to minimize self-citations, you feel that's the right thing to do. How do you do that without hurting yourself? Point blank, I'm not really sure. I'm not really sure. I think, possibly adding these types of statements. I know places have, or folks have been recommending like a gender diversity statement and things like that. I think trying to include a self-citation statement might be a good way to kind of just bring this issue to the forefront. Maybe talk about it, in various applications, things like that. But yeah, I will admit I don't have a great answer for that, unfortunately.
Thank you, Dustin. No, that's actually a very interesting suggestion to add sort of self-citation disclaimer at the end of sort of publications or in applications, and I might definitely take that advice on board. Okay, so I think we have two other questions. One is a short one. Why do you think citation rates vary across research fields?
Yes, so I'm happy to take that one. So I think one of the reasons was just the number of authors in a given field, right? So if you have a field, I think clinical trials papers tended to have a ton of authors. So naturally, if there's a ton of authors per paper, our definition of self-citation rate is going to be generally higher for that field than a field with only a few authors per paper. And another potential reason that it may differ by field also goes back to specialization. If it's a much more niche field, then we would expect self-citation rates to be higher because there's probably not too many other people doing your work, so you need to cite your own previous works. But yeah, thank you for that question.
Lovely. We actually got another question in the meantime, so we have two more, but I think we're okay in the time that we have left. Okay, so the next question is, amazing talk, thanks. What, in your opinion, would be a more accurate metric of research or researcher impact?
Yeah, I can take a stab at that, but if you have any thoughts, feel free to jump in too, Matt. Yeah, that becomes a really interesting question, and I was also having this conversation with an editor of a journal here at Yale. We were having a back and forth on that, like what is a good metric? There's a couple. You could certainly, obviously an H-index has been pretty popular these days as metrics, and there's better versions of that, or putatively better versions of that can start correcting for some of these. Same with self-citations. There's other ways of kind of, so you could do your H-index excluding self-citations and things like that. One of the real tricky things, though, to kind of maybe go one step further than that is just the concept of metrics, right? I understand why people want them. They're quick, they're easy. We want things quantitative as scientists, right? And you can look at these numbers and get a sense of them, even if you calibrate them for different fields, right? Some fields publish a lot more than others, and things like that. The issue, though, with metrics is ultimately you can hack almost any metric, right? You can find ways of scheming to increase that metric, right? So I don't know if there is a metric that's always going to be future-proof, right? I think there's this discussion on Twitter recently, or maybe a couple weeks ago, about someone, bragging that their H-index is over some ridiculously high number, and then people were just talking about how a lot of it actually is publishing in the same journal and a lot of self-citations and things like that. So I think it's almost in some ways the wrong question, in that, can we start moving away from metrics? Because I think anything ultimately is going to be hackable, is going to be able to be taken advantage of. Maybe some are more robust than others, but I think I do think any measure or metric, someone will find a way to game it.
Brilliant. Thank you so much for that. And we have time for one more question, so I'm just going to go through that now. So Great talk, thanks both. Your selection criteria were, inverted commas, high impact journals. The description itself is problematic, but these impact factors are driven by citations, which may be by the same authors driving them in these journals. A possible confound? I know other studies have examined whole journal fields rather than specific journals. Thanks.
Yeah, that is an excellent point. And we do agree the idea of high impact factor journals is problematic in this sense. I do think that we did look a bit into the relationship between impact factor and self-citation rate, and there was definitely a positive relationship, but it wasn't necessarily super strong. Although I do definitely agree that is an important confound to look further into in the future.
And one point there to point out a bit is, yeah, that's something we're looking into. We kind of realized that after we put out the preprint of, oh man, maybe we're in a biased sample here. For the neuroscience journals, in the category of the neuroscience journals, the impact factor did have a much more limited range, or seemed to really be on those high double-digit levels. But for the neurology and the psychiatry, we did start getting a good range of the impact factors, and definitely we're getting more, like specialty journals for maybe like a specific disorder or condition. So I think those probably have a little bit more of a range, but that certainly is a confounding factor, possibly explaining some of the differences that we saw between some of the results Matt showed very early on between the different fields. So it is something that we're actively looking in, because it could change for quote unquote lower impact journals, which I agree. I'm kind of cringing as I say high and lower impact journals myself. So good point though.
All right, brilliant. Thank you both. We've just reached the end of the hour. Just want to remind everyone, first of all, just to say thank you all for joining, and thank you for being so engaged in the Q&A. There is a lot of very interesting questions to be answered by the speakers. And just before you head off, just a reminder that we will post a recording of this session on YouTube. So please do share it with your colleagues if they haven't been able to attend sort of live today. Thank you, everyone, and have a good rest of the day. Bye.